12.3 talks about geometric sequences. A sequence of the form A, the next term is A1 times R. You multiply by R again. You multiply by R again. So kind of like the geometric is kind of like the arithmetic sequence. Instead of adding a number, you're multiplying by a number every time. It's called a geometric sequence where A sub 1 is the first term, R is the common ratio. To find this R, take any term and divide it by the previous term. So to undo multiplication, you divide. To undo addition, you subtract. Common difference, common ratio of the sequence. And the general term is given by A sub 1 equal A sub n equal the first term times this common ratio raised to the n minus 1. So the general term of a geometric sequence is given. Find the first four terms and the common ratio. A sub 1, if you put a 1 in there, you get 2 to the 1, that's 2. A sub 2, put a 2 in there, you get 2 squared, which is 4. A sub 3, 2 in there, 2 cubed is 8. And A sub 4, put a 4 in there, that's 16. The common ratio is any term divided by the previous term. So this here is a sequence in which you're multiplying by 2 every time. Second problem, A sub 1, if you put a 1 in there, that's a 0 power, so that is 2 times 1, which is 2. Second term, put a 2 right there, that's 2 times negative 3 to the 1, that's negative 6. A sub 3, put a 3 in there, 3 minus 1 is 2, 2 squared is 9, times 2, that's 18. A sub 4, well you can guess, you multiply by negative 3, multiply by negative 3, since they told me it's geometric, multiply by negative 3, that's negative 54. And the common ratio is take any term divided by the previous term. You're multiplying by negative 3 every time. Second problem says, well, find the general term of a geometric sequence. This you have to memorize. The summations I provide on the exam, but both general terms of arithmetic and geometric you need to list. So A sub n is the very first term, that's a 3 in this case, times negative 1/2 raised to the n minus 1. There it is, done. Once you know A sub 1 and R, just like we figured out A sub 1 and D for the arithmetic, for geometric you need the common ratio. Here, A sub n is the first term times R raised to the n minus 1. They didn't give me R, but they told me this is geometric. So take any term and divide it by the previous term. And there it is. Now that you've seen arithmetic, geometric behaves pretty much the same, just multiply instead of adding. The first four terms of a sequence are provided. If it is geometric, find the common ratio. Well, let's see. If it is geometric, take 9 divided by 3. That is 3. So check. If you multiply 9 by 3, does that give you 27? No, it wouldn't. So this is not geometric. Actually, that is 3 to the 1, 3 squared, 3. No, it's not even. I thought it was 3 cubed. It's not. That's neither. There are an infinite amount of sequences. Very few of them are arithmetic and geometric. We're focusing on this because we're going to use them, but how about here? Well, if this is geometric, then R should be any term divided by the previous term. So that would be 1/2. If I take negative 10 multiplied by a half, that's negative 5. Of course, the first is going to work. Multiply 5 by 1/2, that's negative 5/2. Multiply negative 5/2 by a half, that's negative 5/4. So yes, it is, and there's R. And here, again, if this is geometric, you take the any term divided by the previous term. That's e to the 6 minus 3, which is 3. If it is, let's see if that works. Multiply by e to the third, you add the powers of e to the 6. Multiply by e to the third, you add the powers of e to the 9. Multiply by e to the third, you add the powers. 9 plus 3 is 12. So it is. Otherwise, I'll cross that and say no, it's not. List the first 4 terms of the sequence, determine if it is geometric. If it's geometric, find the common ratio and write it in this form. Remember, arithmetic and geometric sequences don't have to obey the a sub n that matches. It could look different. Here, a sub 1 is 2 plus 4, that's 6. A sub 2 is 2 plus 16, that is 18. A sub 3 is 2 plus 4 to the third, that's 64. That is 66. A sub 4 is 2 plus, what is that? 64 times 4, 256, I think it is. 258. Is it geometric? Well, what do you multiply by 3? If you multiply by 3, does that give you 66? No, so this is not geometric. Not every sequence that you multiply is geometric. There are a lot of those that are not. Such as this problem. How about here? If I let a sub 1, that is 3 times negative 1, negative 3. A sub 2, that is 3 squared times positive 1, 3 squared, that's a 9. A sub 3 is 3 cubed times negative 1, that's negative 27. And a sub 4 is 3 to the 8 times positive 1, 3 to the 4th, that's 81. So in this case, multiply by 3, negative 3. Multiply by negative 3, that does work. Multiply by negative 3, that does work. So yes, the common ratio is negative 3, and a sub n is the first term times n minus, times r to the n minus 1. And you notice those have the same base. If you multiply those and combine, you could get something else, but that's all we want. We want it in this form. How about here? A sub 1, 2 times 1 is 2. A sub 2, 2 times 2, that is 4. A sub 3, 2 times 3, that is 6. A sub 4, that is 2 times 4, that's 8. Multiply by 2, that works. Multiply by 2, that doesn't give you a 6. So that doesn't work, so this is not geometric. Again, these are the even numbers, and even numbers, you're not multiplying by the same amount every time. You're adding 2 every time, yes. Oops, how did that happen? And how about, okay. How about this problem? The next example, given a geometric, so we know this is a geometric sequence, find the common ratio, the general term, and the 10th term. Well, if this is geometric, r equal any term divided by the previous, I'm going to take 6 divided by 12, which is 1/2. The general term is the first term times r raised to the n minus 1. Got it. And the 10th term, a sub 10, is going to be 48 times 1/2 raised to the 9. If you have a calculator, you plug that in. Otherwise, you could leave that as is. That's not a problem. It's the same thing. Here, this is geometric. R equal, take any term. The general term, a sub 1, times r raised to the n minus 1. And the 10th term. If you put a 10 in there, that's a 9. Here I could find it with ease. That is 3 to the 9x. And when you multiply terms with the same base, you simply add the powers. So this is running smoother because we already did arithmetic sequence, so we're used to this somewhat. Find the indicated term of this is a geometric sequence. The first term is 1 over 10. Very good. The second term is negative 1/2. That means the common ratio is negative 1/2 divided by 1 over 10. The common ratio is negative 1/2 times 10 over 1. The common ratio is negative 5. So if you multiply this by a negative 5, you get negative 1/2. And the general term out of this, so the goal is to find the general term, is the first term times r raised to the n minus 1. That pretty much helps with almost anything. And if I want the fifth term, a sub 5 is going to be 1 over 10 times negative 5. If you put a 5 right there, that will be 5 minus 1, which is 4. This is 1 over 10 times positive 625. And that simplifies into 62.5. You could leave it as a fraction. You could write it as a decimal. It really doesn't matter. And here, the sixth term, a sub 6, is a sub 1 times r raised to the 6 minus 1, which is 5. That's 20. And the third term, a sub 3, is a sub 1 times r. 3 minus 1 is 2, is 160. Now, I could do a couple of things. I could use substitution. I could say, look, a sub 1 is 20. So this is a system of equations. 20 over r to the fifth. Take this and substitute that right there. And this will become 20 over r to the fifth times r squared equal 160. So I could say 20r cubed, r to the negative 3 equal 160, or here, even better. I could say 20 over r to the third equal 160. So 20 equal 160 r cubed equal 20 over 160. R cubed equals 1 over 8. Cube root both sides. R is 1/2. Got it. And if I know that R is 1/2, then I could say, well, let's go back. A sub 1 is 20 divided by 1/2 to the fifth power. That is 20 times 2 to the fifth. Now 2 to the fifth power, 2, 4, 8, 16, 32. So I could say a sub 1 is, what is that? 2, 4, 640. So the general term is 640 times r raised to the n minus 1. The third term of a geometric sequence is a sub 1 times r to the second equal 9. The fifth term is a sub 1 r to the fourth is 81. Which term is this term? Well, let's see how this works. I need to find the general term first. Replace the general term by this. See if n is an integer, then it will be there. So if I solve this, this says a sub 1 equal 9 over r squared. So if I take this and I substitute it right there, that would be 9 over r squared times r to the fourth equal 81. That would be 9 times r squared equal 81. R squared equals a 9. R equal plus or minus 3. So the general term would be, oh, and a sub 1 would be 9 over 9, which is 1. So this starts with 1, then a 3, then a 9, that's the third term, then 27, then 81, that's the fifth term. Or it's 1 multiplied by a negative 3, multiplied by a negative 3, that's the third term, matches, multiplied by a negative 3, and multiplied by a negative 3, so it could be either plus or minus, right? Either way, well, let's see how this works. If I take the plus term, so a sub n is either a sub 1, which is 1 times 3 to the n minus 1, or it is negative 3 raised to the n minus 1. Either way, is this on the list? Is 531441, is that one of the powers of those? Well, how do I solve that? This is an exponential equation. I would say log base 3 of 531441 equal n minus 1. So n minus 1 equal, and if I use the change of base formula on this, take natural log of that number, natural log of 531441 divided by natural log of 3. It's an integer. I'll get that to be 12, which means n equal 13. So we know that a sub 13 is 531441. If you use the negative, it gives you the same exact thing. Yeah, this is an odd term. Now, in a geometric sequence, we have two of them. First geometric sum, if you want to add a finite sum, that is the first term into 1 minus r to the n divided by 1 minus r, provided this r doesn't equal 1. I provide that formula on the list. You don't have to memorize it. So if I want to use it, find the partial sum of the geometric sequence that satisfies the given condition. What I need the first term So to use this, I need first term, I need r, and I need n. Well, first term is 1, I got it. And r is, obviously, since that's a 1, take negative 1/3 divided by 1, that's negative 1/3. N, I don't have. I don't know how many terms are those. So to figure that out, I need to figure out the general term. The general term, a sub n, is the first term into r raised to the n minus 1. And I want to know, where does that equal negative 1 over 59049? Now, we have an issue, a small issue. This is a sequence. I could rewrite this. You know what, I need more space, let me do that first. So I could say negative 1 to the n minus 1 over 3 to the n minus 1 equal negative 1 over 59049. I could solve this equation and worry about the negative later, because if I'm using logs, I can't have negatives. So if I want to solve this equation, I could say n minus 1 equal log base 3 of 59049. I could plug that in my calculator and figure out what n is, and again, I could say take log of 59049 divided by log of 3. That's 10. So n equal 11. So now that I have n equal 11, I could say S sub 11 is, and here's the formula. Again, I'm providing this formula. The first term is a 1. 1 minus r. Now what's r? R is negative 1/3. Raised to the n. N is 11. Divided by 1 minus r. Now, on a test, you could leave your answer like that. I could plug this in a calculator and say, well, okay, that is 1 minus a negative 1/3 raised to the 11, and divide that answer by 1 plus 2/3. And there it is, 0.6666, whatever that is. Of course, you could leave it as a fraction if you wish. You could work it out a bit more. You know, you could say, well, that is 1 plus 1 over 3 to the 11 over 1 plus 1/3 is 4/3. I did divide by 4/3, right? Yeah. Right? And you could say that is the LCD is 3 to the 11, multiply this by 3 to the 11, 4 times 3 to the 10. You could do that if you wish. It doesn't matter. To me, it's all the same. Same deal with this problem. This is geometric. Well, I need the first term. The first term is obviously a 2. The common ratio, take 4 divided by 2, that is 2. And I need n. So I could say, well, let's see. The general term out of those is 8192 is going to equal the general term, which is a sub 1 times r raised to the n minus 1. There it is. You could divide by 2 both sides if you wish, make it a bit nicer. That's a 4, and 2 divides 19 9 times, you have 1 left over. 2 divides 12 6 times. I missed a 0, didn't I? Well, anyways, you have a calculator, you could use it. Yeah, I missed a 0, 4,000. So 8192 divide, I should also assume things in my head. 4096 equal to 2 to the n minus 1, and again n minus 1 would be log base 2 of 4096, and if I plug this in my calculator using the change of base formula, natural log of 4096 divided by natural log of 12. So n equals 13, so you could say, well, s sub 13 equal the very first term into 1 minus r is 2, to the 13 divided by 1 minus r. Again, you could leave it like that on a test, out of mind. You could plug it in a calculator. You could, as you see it, you could say that's 2 times 1 minus 2 raised to the 13. You could do the whole thing one shot if you like, divided by 1 minus 2, literally as you see it. There it is, 16,382, 16,382. That's good enough, not a problem. And let me see what we have left. I have one more thing to talk about, so I'm going to wrap it up in this video. If you have an infinite sum, that infinite sum from n equal 1 there you go, to infinity, that will equal the very first term divided by 1 minus r if absolute value of r, meaning if r is between -1 and 1, and if the absolute value of r is bigger than or equal to 1 or less than or equal to -1, this sum diverge. Determine whether the infinite series converge or diverge. If it converge, find the sum. Well, what's r? Take any term divided by the previous, that's less than 1. So this infinite sum, if you add all of those up, that's going to equal the very first term divided by 1 minus r. That infinite sum is 4/3. Similarly, if I look at this, this is a geometric sequence. You're multiplying by -1 every time. In absolute value, that is not less than 1. So this diverge. And the third example, take r, that is any term divided by the previous term, that's 1/5. Well, this sum, if you add 20 plus 4 plus 4/5 plus 4 over 25 plus 4 over 125, will be the very first term divided by 1 minus r. That will be 20 divided by 1 minus 1/4. That is 80 over 4 minus 1. That is 80 over 3. That's what the infinite sum equals. And that's pretty much it for this section.